Now let us discuss about the binary search tree. Binary search tree. Binary search tree in data structure. First, binary search tree is a class of binary tree. In binary, in which nodes are arranged in a specific order. It is also called as ordered binary tree. First, in binary search tree, it comes from binary search. In binary search, we'll arrange the elements in the sorting order. Like this, in here, in binary search tree, we'll arrange the elements in the sorting order itself. The tree will be in the sorting order. In each node, binary search tree has at most two children. It may be zero child, it may be two child, it may be one child. The tree may consist of one child, two child, and zero child. The value of left subtree must be smaller than the root node, and the value of right subtree must be greater than the root node. The rules, this rules is applied recursively to the left and right subtree of the root. In whole tree, the left subtree must be lesser than, the right subtree must be greater than. This hierarchical structure allows for efficient searching, insertion, and deletion operations. For example, here, let us consider 40 as a root node. The left subtree of 40, the left subtree of 40 node will be lesser elements, such as 30. 30 is smaller than 40. Next, 25. 25 is smaller than 30. And 30 is greater than, 35 is greater than 30, like that. Suppose if you want to insert 32, then it moves to left subtree of 30, left subtree of 40 and right subtree of 30. Now, it moves to the left of 35. It moves to the left of 35 if you want to insert 32. Suppose if you want to insert 48, then it moves. Now 48 will be moves to right of 40, then it moves to left of 50, then it moves to right of 45. Like that, it will be inserted. The left subtree will be smaller elements, the right subtree of the node will be larger elements. Advantages of binary search tree. Searching is very efficient in binary search tree as we get a hint at each step about which subtree contains the desired elements. If we want to search an element, then directly we can move to the particular step. Suppose here we want to search an element 35. First, directly we move to 40, then we move to 30, then we move to 35. Why? Because the right subtree of the 40 is all the larger numbers. That's why directly we can move to the particular step. As comparing to the arrays and linked list, insertion and deletion operations are faster in binary search tree. Let's consider an example to create the binary search tree. Suppose take an elements like 45, 50, 79, 90, 10, 15, 12, 20, 15. First we have to take 45 as a root node. first, we have to take 45 as a, first we have to insert 45 as a root node as it is an first element. Then next, then it moves to next element. Then it moves to the next one. The next element should be compared with root node. If it is lesser than root node, then it moves to the left. If it is lesser than root node, then it moves to the left. Otherwise, it moves to the right. If it is larger than root node, then it moves to the right. Now, in step 1, first 45 as a root node. Next, 45 as a, in step 1, 45 as a root node. Next, in step 2, suppose insert 15. 15 is smaller than 45. 15 is smaller than 45. So, insert it as a root node of left. 15 is smaller than root node. So that we have to insert 15 to the left of 45. Next. In step 3, insert 79. As 79 is greater than 45. As 79 is greater than 45. So we have to insert the 79 for the right of 45. We have to insert the 79 for the right of 45. Now, next step, insert 90. 90 is greater than 45. Then it moves to the right and check the next node is 79. The next subtree node is, the right subtree node is 79. 90 is greater than 79. Again, then it moves to the right of 79. So, 90 is greater than 45. 90 is greater than 79. So, it will be inserted as right of 79 subtree. Okay. So, it moves to the right of 79 subtree. Next, insert 10. 10. Next, insert 10. 10 is less than 45. 10 is less than 45. Then it moves to left. And it will check with the next subtree. Then 10 is less than 50. 10 is less than 45 and 10 is less than 15. So, it moves to left of 15. So, it moves to the left of 15. 10 is less than 45 and also 15. So, it is inserted as left subtree of 15. Next, in next step, insert 55. Insert 55. 55 is greater than 45. 55 is greater than 45 but lesser than 79. Now, see here 55 is greater than 45 but not 75. 55 is lesser than 79. That's why the 55 moves to left subtree of 79. See here, insert 75. 75 is greater than 45. 75 is greater than 45 and smaller than 79. So it will be inserted as left subtree. So it will be inserted as left subtree of 79. Next, insert 12. 12 is smaller than 45. 12 is smaller than 45 and 15 is, 12 is, now let's insert an element 45. 12 is smaller than 45 and then it moves to left. Now 12 is smaller than 15. Then it moves to left again. then it moves to left again. Now it compared to the next element 10. 12 is greater than 10. 12 is greater than 10. Then it moves to the right of 10. Then it moves to the right subtree of 10. Okay. Insert 12. 12 is smaller than 45. 12 is smaller than 45. And 15 is, and 12 is smaller than 15, but greater than 10. So it will be inserted to the right subtree of 12. Next, in step 8, each insert 20. 20. 20 is lesser than 45. 20 is lesser than 45. Then it moves to the left. Next, it will check with the next element 15. 15, next 20 is greater than 15. 20 is greater than 15. So it moves to the right of 15. So it moves to the right of 15. Next, insert 50. In next step, insert 50. 50 is greater than 45. 50 is greater than 45. Then it moves to the right. Next, it will check with the next element 79. Next element is 79. The next of 45 is 79. 79. Now 50 is lesser than 79. 50 is lesser than. If it is lesser, it moves to the left subtree. It moves to the left of 79. Again, it will check at 55. Now 50 is lesser than 50 is lesser than 55. Again, it moves to the left. Now, the element 50 will be inserted at left subtree of 55. The element 50 will be inserted at left subtree of 55. Now, the creation of binary search tree is completed. Now, let us check that. Let us see 45. 45 is a root node. The left subtree of 45 elements are the smaller elements. The right subtree of 45 is all are the greater elements. Next, search an element in binary search tree. Search an element in binary search tree. Searching means to find an element in the data structure. Searching is nothing but it is to find an element in the data structure, or it is to find the location. It is to find the location in the data structure. It will be here in searching is nothing but it is to find an element in the data structure, or else it is to find a location in the data structure. In binary search tree, searching an element is very easy because elements in binary search tree are sorted in specific order, like ascending order, It will be sorted in the ascending order. The left subtree will be smaller elements. The right subtree will be the greater elements. That's why it is in the specific order. Now, it has some steps to follow to search an element. It has some steps to follow to search an element in binary search tree. First step, compare the element to the searched. Compare the elements to be searched with the root element of the tree. First, we have to compare the root element with the targeted element. Suppose whatever the element we have to search, whatever the element we want to search, that element we have to search with the root element. If the root element is matched, if it is matched, then the targeted element will be return the location of that particular node. Otherwise, If not matched, then it checks whether the elements is lesser than the root node or whether the element is lesser than the root node. If it is lesser than, then it directly moves to the left subtree. Or else, if it is greater than the root node, then it moves to the right subtree. Repeat the above procedure recursively until match found. Until the particular element found, repeat. We have to repeat the particular steps until the element found. If the element is not found in the tree, then it returns null. Now, now let us take an example to search an element. Now, for suppose, search an element 20. Now, search an element 20. Here, first, this is the example we have inserted before. This is the example we have inserted before. Now, we want to search 20 targeted element. First, 45, we have to assign 45 as a root node. 45 as a root node. Next, target. What is the targeted element? 20. Targeted element is equals to 20. Then we have to find whether the target root is lesser than the targeted or greater than the targeted. Now, targeted element is lesser than root node. Targeted element is lesser than root node. Then we have to move. Then what we have to do? Root is equals to, if it is lesser, then what it happens? Root is equals to root of left. Then it moves to the left of root node. Next, it moves to the next step. In step 2. Now, in step 2, next we have to, the next element 15 will make as a root element. The next element 15 will make as a root element. Now, the targeted element is 20. Now, 20 is greater than root data. What is the root data? 15. Targeted element is 20. 20 is greater than 15. It is greater than. That's why what happened? Root is equals to root of left. The root will move to the root of next. It moves to the next position to search. What is the next position to search? It moves to the right. Now, finally, next step. Now the target root element is 20. The targeted element is 20. 20 is equals to 20 of data. Root data is 20. 20 is equals to 20. Now we found the 20 element in this position. It will return the root of 20. This is the searching process of binary search tree. Okay. Thank you.